In this video, I will show you how to perform combinations of transformations. That means we're going to do two or more transformations in a row. So really, the bottom line is still that you have to know these rules right here. These 7 rules are key, if I can just fit them on the screen here. All right, you have to have these 7 rules memorized. Because we will be performing 2 or more of these rules in a row in most cases. So for problem number 1, we are being asked to reflect the image across the x-axis, then dilate by a scale factor of 1/2 from the origin. Now I'm going to skip down to problem number 3 a little bit here because it says write down the rules that you need to help you work out problem number 1. So when you do a reflection over the x-axis, the x value stays the same. So the point xy will become x negative y. Okay, reflection over the x-axis, the x value stays the same. The y changes signs. We need to dilate by a scale factor of 1/2 from the origin. When you dilate from the origin, all you do is multiply by the scale factor. So since the scale factor is 1/2, this will simply be 1/2 x, 1/2 y. So these are the 2 rules that we'll need to help us work out problem number 1. All right, I'm going to set up sort of a little chart here to help me stay organized. Because we have 2 transformations, I'm going to use the following type of procedure. You know how the original point, let's say we have h, point h. When we do a transformation, then it becomes h prime. If we do another transformation, then we must call it h double prime. So that's what I'm going to do. All right, let's start with point h. So we need to write down point h, which is the point 0, 0. Okay, and what's going to happen to that? If we reflect across the x-axis, all right, this is h prime. Reflecting across the x-axis does not affect this point. So it's still going to be 0, 0. Okay, and then we have to dilate by a scale factor of 1/2 from the origin, and that's going to be h double prime. But taking half of each of these is still going to be 0, 0. All right, so that's h double prime. Okay, now I feel like switching colors. Now I'm going to do point E. All right, point E is -2, -4. Okay, now let's talk about, that looks like E prime. Let me fix that. I don't want any confusion. All right, this is point E, and now we're going to have E prime. Okay, so we are reflecting across the x-axis first. So the x value stays the same. So this should be -2, the y value changes. So it'll be -2, 4. So there we've done the reflection. Now let's get E double prime. This is where we dilate by a scale factor of 1/2 from the origin. So we're just going to take half of each of these. Half of -2 is -1, and half of 4 is 2. Okay, maybe I should plot these as I go. So h double prime is 0, 0. Now I've got E double prime is -1, 2. So this is E double prime. Okay, now let's go ahead and get F. F is at 2, -5. Feel like changing colors though. All right, f is at 2 comma negative 5. When we reflect across the x-axis, we will get f prime. The x value stays the same. The y value changes. So there we've done the reflection. Now it's time to do that dilation by a scale factor of 1/2 to get f double prime. So I'm just going to take half of each of these. Half of 2 is 1. Half of 5 is 2.5. Okay, so f double prime should be at 1 comma 2.5. So that's going to be right here. Okay, there's f double prime. And last but not least, we will do point L. Point L, the original point is 3 comma 0. When we do the reflection over the x-axis to get L prime, the x value stays the same. The y value becomes the opposite, but the opposite of 0 is still 0. So that point did not move so far. So that was our reflection over the x-axis, and it was on the x-axis, so it didn't move. Now we need to do a dilation from 0, scale factor 1/2. And this will give us L double prime. Half of 3 is 1.5. Half of 0 is still 0. Okay, so 1.5 comma 0 would be right here. Okay, so this will be L double prime. So now we can just connect the dots and reveal the shape. So there's the image after both of those transformations, and be sure to show your work like I just did right here. For problem number 2, we need to do a reflection across the y-axis, then translate up 4 units, then reflect across the y-axis again. All right, so write down the rules. So I'm going to skip down to number 4 because they're asking us to write down the rules we will need to help us do problem number 2. So if I want to do a reflection across the y-axis, I know that the y value will stay the same. So x comma y will become negative x comma y. See how the y value stayed the same. And we'll use that twice. But in the middle there, we need to do a translation of up 4 units. So up 4 units, that's a translation. So because we're moving up, that's going to affect the y value only. So the x value will stay the same, but the up 4 will be y plus 4. Okay, these are the 2 rules we'll need for problem number 2. Okay. So as you can see, I've started off by writing down the 3 original points, B, R, and W. I've written the coordinates here. So next we need to find B prime, R prime, and W prime. So let's start with B prime. Now remember, our first transformation is reflection across the line, reflection across the y-axis. When you reflect across the y-axis, the y value stays the same. Okay, the x value changes. So this is going to be negative 3, comma, negative 3. All right, see how the y value stayed the same. So let's see, how about r prime? Again, the y value stays the same. So this should be negative 2, comma, negative 2. Notice how the y value stayed the same. And for w prime, I should have negative 1, comma, negative 5. Notice how the y value stays the same. So we did the first reflection across the y-axis. Now we need to translate up 4 units. All right, and that is going to give us the double prime. Okay, so this is going to become, hold on, I meant to put the little arrows on. before I change colors. Okay, so now I need to find B double prime. If we're going up 4 units, that means we're going to add 4 to the y values. Okay, so basically I'm going to add 4 right here. I'm going to add 4, and I'm going to add 4, like that. So -3 plus 4 is 1. So I'm going to have -3 comma 1. For r prime, r double prime, I'm going to keep the -2. -2 plus 4 is +2. Okay, and then for w double prime, we'll keep that -1. -5 plus 4 is -1. Okay, so now I have reflected across the y-axis, and I've translated up 4 units. Now it's time to reflect across the y-axis again. Okay, let me go ahead and draw my arrows before I change colors. Okay, now this is going to be the final answer. Okay, so this is going to be B triple prime. So again, when you reflect over the y-axis, the y value stays the same. The x value changes. So this is going to be +3 comma 1. And r triple prime, the y value stays the same. So this will be +2 comma 2. And then w triple prime, the y value stays the same. So this will be +1 comma -1. And this is the final answer. So let's see, 3 comma 1. Okay, 2 comma 2. And 1 comma -1. Okay, so 3 comma 1 was our B triple prime. 2 comma 2 was our R triple prime. And this is W triple prime. So now I'm just going to draw the triangle. All right, so that's what your image should look like after you've done the 3 transformations. Okay, so at this point we've done number 1, number 2, number 3, and number 4 already. So let's see what number 5 is all about. What rule do you use to rotate an image around the origin 90 degrees counterclockwise? Well, and this is just straight memorization, but when you do a 90-degree rotation, this is one of the ones where the x and y switch places. Regardless of whether it's clockwise or counterclockwise, the y is going to be first and the x is going to be second. Now, you have to memorize one of these is going to stay the same and one of them will become negative. When you're going counterclockwise, the x value stays the same. When you're going clockwise, the y value stays the same. So this is counterclockwise, so the x value is going to stay the same. The y value is going to change to the opposite of what it was. So this is the rule that we're going to use. And again, all right, it's all on the list. All right, this is just straight memorization. Counterclockwise, that's the CC right here. Yeah, so counterclockwise, the x value stays the same, the y value changes. What rule do you use to rotate an image 90 degree clockwise? Well, we basically just already talked about that. So it's going to be, again, we're going to switch them, reverse them, but this time the y value will stay the same and the x value changes. These are the 2 most easily forgotten rules. So just take a moment to just memorize them. Just practice them over and over again. Write them down on a scrap of paper and then look back and check and do it over and over again until you nail it. Anyway, moving on. Number 7, use the graph of the triangle to the right to answer 7 through 9. Reflect this preimage over the line y equals -1, followed by a reflection over the line y equals -7. Draw the new triangle. Okay, let's start with reflection over the line y equals -1. All right, I'm going to zoom in a ton. Okay, y equals a number is a horizontal line. So the line y equals -1 is a horizontal line at -1. Now be careful, I had to redo this part of the video actually because I started it off by putting a line at this first square down, but they're counting by 2's. So -1 is really half a square down because they're counting by 2's. So be careful to do that. So this is the line y equals -1. So we need to do a reflection over this line. Okay, so all right, so this first point is, I'm going to use the squares just to help me count, but see how it's 1.5 squares away from the line? So there's my half, and here's 1. So this is 1.5 squares on the other side of the line. Okay, now this point way up high is, let's see, 1, 2, 3, 4. It's 4.5 squares above this line. So there's my half, and then now I'm going to go 4 squares below the line. So that's going to be right here. Okay, now this last point is 3.5 squares above the line. So I need to go 3.5 squares below the line, and that's going to be right here. So I'm not going to connect these dots because this is not the final answer. Okay, so we still need to do a reflection over the line y equals -7 now. So let's go ahead and draw the line y equals -7. That's going to be another horizontal line, and again it's going to be between the lines. All right, it's a little bit hard to do floating in the middle like this, but this is the line y equals -7 because they're counting by 2's. This is where it goes, in between -6 and -8. Okay, so we're going to have to be very, very careful when we do this. I think I'm going to zoom in even more. Okay, so I'm going to change colors so you can tell the difference. So I need to reflect each one of these 3 points over this horizontal line. So this first point is 1.5 squares above the line. So I need to go 1.5 squares below the line, and this will be the final answer. This next point is 1.5 squares below the line, so I need to go 1.5 squares above the line, and that'll be the final answer. The final point is half a square below the line, so I'm going to go half a square above the line. So now these red dots will reveal the final answer. I'm just going to connect them. All right, so this is what the image would look like after the 2 reflections. All right, so that was it for number 7. But then for number 8, they want to know what transformation is this double reflection the same as? Well, hopefully at a glance you can see how these triangles are facing the same way. They're not rotated, they're not backwards, they don't look like reflections of each other anymore. So really, to get from the blue triangle to the red triangle, all you would have to do is move down a certain number of units. Let me zoom in again for a second. Now if we counted the squares, all right, just pick a pair of corresponding points like this point and this point. All right, this is 1, 2, 3, 4, 5, 6 squares. But we're counting by twos, so this is really 12 units. So we could get from the blue triangle to the red triangle just by moving straight down 12. So this would be the same as a translation down 12 if we wanted to write it as a single transformation instead of a double reflection. So what would the rule be? Well, that's easy. So xy becomes, so if we're just moving down 12, moving up or down only affects the y value. So the x value is going to stay the same. And the y value will become y minus 12 because down 12. All right, that's a good place to stop this video. On the next video, I will do the second half of this worksheet. So I will do the rest of these problems on the next video. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.